In this section, we would be covering the data jargon. But before we get into the nitty-gritties of the jargon, let us look at data in our day-to-day life. All of us are very familiar with this page. Yes, this is the Facebook home page. It allows us to connect with our friends which are sitting in faraway geographical locations. It's a very famous social networking site. So the moment I provide the system with my email or phone and my password and I hit onto this login button, it takes me to my home page. Now, whatever information is displayed on this page has close relevance to the person by which I have logged in. So, any updations that have been made, as in photographs being uploaded, any status messages being changed, my friends, my acquaintances, everything gets displayed on this page. It will not allow me to view the page for any other person. The restriction is happening at the database level. So as of now, we only thought of Facebook as a social networking site. However, it is actually hitting a database in the backend. The moment I'm clicking onto the login button, it's displaying this page by hitting onto the database and getting the retrieved information. A lot of internet shopping is happening these days. We have a lot of sites like Myntra.com, Amazon.com, which allow us to do shopping sitting in the comforts of our home. Also, for people who are interested in stocks, we have Nasdaq.com. So there are a lot of sites available which are nothing but having a database in their backend. Now let's have a look at this number 18. As a lot of people are there, each person will have a different point of view of looking at this number. For some, it is an age. For some, it might be the number of seats that are left in the bus. For some, it might be the number of the ticket that he has, so on and so forth. So this is giving us not much of information. But yes, it definitely is a fact. So when we talk of this, it contributes to become a data. So we can say that data is nothing but a collection of raw facts and figures. Now let us give some more meaning to this number 18. We'll say age is equal to 18. The moment we have associated this number 18 with age, we definitely know that 18 is not the seat number, not the number of seats which are left, but is the age of a person XYZ. So this becomes our information. So when we talk of information, information is nothing but the final product which gets created from raw data after processing. Let us have a look at this table. At the first look, this feels as if this belongs to a student database. Now, why do I say student database? Logically, if you look at the age column, it speaks of ages as 18 or 19. So this probably is the age we look at for students. It is giving us details like the name, the age, and the email address. Each row pertains to one particular student or one particular person. Now, these are interrelated information. All the information put together contributes to becoming a database. So, when we talk of database, a database is nothing but a collection of related information which is organized in a structured manner, and it contains information which is relevant to an enterprise or an organization. So we cannot have records which do not belong to the same domain. As in, I cannot put the student and the employee record together and form a database. Each record should have some link to each other, and they should definitely belong to the same enterprise or organization. Now, I have got all the data that I wanted. It's put together, it's related to each other. What do I do with this data? Yes, I need to retrieve data as and when required. So, I have data in place. I need to have some mechanism to get the desired data. A DBMS is nothing but a collection of interrelated data and a set of programs to access the data as and when required. Later on, we'll be talking about DML and DDL, the SQL, which helps us to retrieve data from the databases.